Okay, testing. Okay, seems like what is this? Crete. Creeks. Wow. Very nice. Very nice. Alright, let's do this. Okay. Started. So sub-arrays equal. Oh wait, hold on, sorry. Okay. Return the total number of sub-array to sum equal to k. Hmm. This look like a sub-array sequence. Okay, so look like a segment tree problem. Right? Or this could be a prefix sum problem. So this plus this, right? Plus this, right? So you want oh, I forgot to put this here. Sub-array sum okay. Right, as soon as we iterate over them, sub-array is a contiguous non-empty sequence of elements or contiguous. Okay. Definition of sub-arrays, that means consecutive. So we can do a window now. Like as soon as we plus them and it's equal, and if we plus another one if it's not equal, then we increase the window, right? Right. Just oh, the number can be negative. So sliding window might not work. So this one has 1 plus 3 and 3. So like, do you start with start with 1, 2, 3, right? Start with 1. Okay, is it equal to 3? No. So 1, 2 is equal to 3, yes. So we got 1. As soon as it's equal to 3, right? But the problem is there will be negative, right? So you could min, max, minus, whatever, right? So this is equal to 3, no, right? Then it fall off to 2, right? So total number of sub-arrays sum equal to k. Okay, so so if we do it like this, right, it looks like an n square solution. Right, no. And then finally you start with 3, let go, yeah. The main problem is the negative. How do we deal with that? Because I think the prefix sum, right? How do you deal with negative? Right. Right. Because basically, let me see if prefix sum would work. Right, so you basically store something like this: 1, 3, and then 6, right? So we found subarray here is 1. Right, how does it do with negative? Would it just work? Right. So if you start with this, you loop them, you found them, right? So basically counting sort. right? So if we ended up here, this is all the starting with 1, right? How do we know? So let's just list all the number, right? 0, 1, 0, 2, 0, 3, right? That's all the range of the subarray, right? But 1 is 2, 1, 3, right? So then 2 to 3. Oh, we also need, so this is actually 1, 1, right? We could also have 0, 0. Right? So then 2, 2, 2, 3, and 3, 3, right? This is all the subarray. So this give you 1, 1, 1, just 1, 2. So the first row is basically 0, 2. Oh, there's no 0, 3 here. Sorry. It's basically this array, right? So this is 2 and 2, 3. Right, so this is 3. Right. So 1 to 2. So this is this minus this, right? So this is 2, right? And one to 2 is basically 5, right? How do we have 5? We minus this. Right, so we start with 1. There's nothing else. And we start with this. We have to minus this, right? So that's 2. And we start with this. So as soon as we look to this, we only know this. But we also know, so this gives us 1, 3, 6, right? This gives us 2, 5. Right, so as we scan through, we got 1, we got 2, and we at this position we got nothing. We got this, we got 2 and 3, and at this we got 5, right? So we got, as we scan through this, we got this number. Do we also, let's say, hold on, let's do 4, 5, generalize them. Okay, so this will get all this number. Two, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7. Okay. Same thing here. We got 1, 2, 1, 3, all the way to 1, 4, 1, 5, 1, 6, 1, 7, right? So basically this gives us, this is the same as this, so this range will just like 1, 1, right? So basically this one is the total sum minus 1, right? Minus the first one, right? And this gives us same thing, so on, 2, 2, 7. So that means the sum of all of this number will give us the ability to get the sum starting from 1, which is minus the first one. This one minus this, minus the first two, right? So basically, as we loop from 0, 1, 2, right? So basically, gonna be total sum at 0. It will be all of these numbers already calculated. Total sum at 0, right? So all of these numbers will just drop 0. Each I minus, so it will be sum at 0, corresponding sum at 0 minus the nums at 0, right? So that's how you get all these numbers. And this will be sum of 0i, no, sum of 1i minus nums of 1, right? And so on. So you get to 7 equals sum of 6, right? Minus num 0, 1, 2, 3, 4, 5, 6, 8. Right? Does that still feel like an O and square problem? Right? Feel like a n square solution though. Can we figure out a solution with ON, right? Take another approach. So this we could do 1, 0, right? 2 is at 1, 3 is at 2. So if we had 1, we need 2, right? So, and then the moment we get 2, we increment them, right? And then we had 2, we need 1, but in this time, oh, so the subset here would just work here, right? And 3 is already there, right? Right? So how do we get over the, let's just implement this approach first and see if it even pass, right? Because this case probably pretty big. And so right, this is the ON square solution, right? So 4 we get all this number, we figure out that prefix sum here, and then we just loop, right? This is what it is, right? Also, right? Let's just see how far does this approach work first, right? Also, like the first time we know, right? We get all of these number, right? As the moment we drop the first, okay, let's just do this. Okay. For minus, okay. For I in range. So first we gotta get our prefix sum, right? Range and nums, okay. I plus equal 0. Let's just print our stuff first to make sure that it's correct. One, two, one. 1, 2, 3, right? Oh. Not including, right? So, okay. Yeah, 1, 2, 3, and 1, 3, 6. Okay. So now we're gonna loop. Then we have, first we got the sum here, and all of these got a minus the sum, right? So basically, so this, so the first sum got this, right? So basically, if BSI equal to K, then we increase the count plus 1, right? So now we basically loop from length of PS, right? For J in range of minus 1 for AI plus 1, right? So this will be PS of J minus equal PS of I, right? And if PS of J equal to K, then K also plus 1, right? This will return the count, right? Right, so I don't know if we're gonna pass the big case, but let's see. We will see. Let's see what it is. Wrong answer. What? Okay, so I'll put 0 because let's see how far we come. If length of nums to 1, then basically it's just going to be num 0. Right, so it's the length gonna be at 1, right? Okay. Submit. Let's see how far we come. Oh, if K equals 0, then return 0. Wow. Time limit exceeded or what? Wrong answer. Oh, I see. Okay, hold on. So k here is the equal number, not right. Okay. If k equals 0 and if num 0 equal k, that's 0, right? Go see. Wrong answer. What? Oh, k equal wrong here. 2, right? What is happening here? Yes. First loop. Second loop. What? If why is it not counting? K equals 0. Why does it not go here? Hello. Hello 2. It does go here. It's after, right? Zero. What is k here? is 0. Right. True. Why is it not counting this? Is this true? Oh, you're missing one. No. Okay, so for this case, okay, okay. So okay. Right. So do we even need this? No, right? Yeah, here we go. Set all the grid line. Okay. See how far we passing. Pretty sure it's gonna be time limited. Yeah. So if there's a way to cut down on these, that'd be great. So looking back to this, so any of these, right? We have somehow know the sum. We do, right? So in order for us to equal k, we know that number gonna be, right? Right? So right, so as we look to these, we want to check, right? So this is the range, right? So as we let me write on the paper and see. Let me check my thinking. So you starting at here, you keep expanding. One element at a time. 0, 1, 2, 3, 4. Okay. So okay, so 0, 1, 0, 2, 0, 3, 0, 4. Right. And then you need 1, 0, delete the one, right? We delete the first one. All of this guy. Delete the 0. We'll make it become that. Right? So basically, as we loop through these, if we somehow know the sum has to be equal to k, right? So basically 0 0, right? 0 1 0 2 0 3 0 4 and so on, right? So if the number is not equal to k, then we need k minus something, right? If k minus something is in is less than n, right? So the numbers, right? So we can find the number, right? Then that would be good. If we do not find a number, we need to find the sum of it, right? Or something, right? So like we have a range that's sum to x, and we need to find k minus x, right? And how do we find k minus x? Right, so let's say we start at 0 0 here. Sum is x, right? The main problem is, how do we do that? How do we optimize this out? I have no idea. But let me get some water. We could say that if the sum is x, and we could put the number in the hash map, right? Because we need that number in order for it to be equal k, right? Right? So But how do we deal with if we enumerate the number of sub-array correctly? Right? And how do we deal with duplicate? Right? So we fix something, right? I still think there might be some solution that I'm missing. What is this? This? Um, what examples they give? Oh. Oh, this is how you do it. Prefix them correctly. Did I do it wrong? Wait, hold on. Let me write down on the paper. Okay. So you have 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5. Right. So right. So if we store them this way, how do we get 1, 2? 1, 2 gonna be 2 minus 0, right? No, but that's fine. The problem is, once we get this, how do we figure out that it needs to sum over k, right? If we if our target is for k, right, we want to go over these like over O1 we need k, so all of this sum is x0, x1, x2, x3, x4, right? So basically for any of these we need to find k minus x0, k minus x1, k minus x2, k minus x3, k minus x4, right? So for example, do they give a better example? So let's say we have 1, 2, 3. Right? 3, 1, 3, 6. Right? Right. So for all of these, we need, starting at 0, we need 5. Is 5 in? No. Right? 3 minus 3 is 0, right? But it's already in, so we're good. So now 3 minus 6 is 3, right? So this is k minus xi, this is xi, right? So this one is expecting 2 because we have a range that is an x, right? So start at 0, right? Get 0, 1, 0, 2, 0, 3, right? 0, 2. We still need to loop over them, right? Which is I can't escape the O(n) square here. How do we optimize this? Okay, this is the one that takes time, right? Okay, but it has to sum to k, right? So sum equal to k. Hmm. Right? So if we loop it this way, right? So if we simply count like this, it will time out, right? Because this is n square, right? Is there any way to not having to sum them or something? Okay. So we have h at the sum here. We cut 0 here, we cut 1, and so on. You have to look to the value, right? Can we go back and forth? Yeah. Let's just go to different question first, because I have no idea how to optimize that. You are given, so let's try this. I have no idea how to do the other one, so let's go through the other question first. See if we can take a stab at them. Merge k sorted list. I've given an array of k linked lists. H king sorted ascending, merge all the k into one sorted list and return it. So you always take the minimum one out of all, right? I think so. Right? Okay. So do you create a new list? Yeah. Okay, sure. Okay. So you probably need you compare these. for these. So you still need an array to, and then sort, right? So this is O. Can we just not use the heap to as a way to, yeah, let's do that. Why not? Heap to queue. Right. What is the constraint here? Can I not can I not push all of them into like a round robin, right? Into a heap and then construct the list myself, right? Or does it want you compare each and then you iterate, right? So try that. Okay, so basically while the list is not empty, right? The list is by index. Right, we get to look at all the lists for I in range of list. Right, we compare both element and all the element at once, right? So so basically if what is it, how is the stock doing? Amazon going down, what happened? Go up. Okay, hold on, let me see. You always have to look to these and get the minimum, right? And as soon as you got the minimum, you tell that to go to the next, right? So basically we have to for sure for I in range of this, right? Get the minimum. Right. First, find the minimum out of all the lists. Find the index of the minimum. The minimum list, right? So basically we need, does the element is greater than 0? Yeah, no, yeah, it can have negative, right? So we have to do min number minimum equal none, right? If minimum equal none or be or list 0, right? Greater than, okay, minimum index as well. Mi, let's call this m and mi. None, -1. So if minimum is none or it is greater than or less than min m, then mi equal list 0, right? And list I 0 and I, right? So basically we need to have a way to track the index, right? Where they are, right? So let's call this list index what is this indices equal this, gonna be 0 multiplied by length of list. So basically while list indices and let's track them in a hash map, right? Zero, 1, 2, right? So basically why the list indices, then we keep doing this, right? Okay. 0, 0, oh no, I 0 4 I in right. So here we do for I in list indices, right? Okay. Okay, so we found the minimum index. We have to L equal none, right? Return L, right? So here we found the number, right? So if not L, then L equal this node, right? The value gonna be M, right? Value gonna be equal M, L dot next equal this node M, right? hold on. If not else, good. Otherwise, we need a head and the tail, front and back to that. So right, back equal F. Equal B dot next. Yeah. Right. So that is the next list. Now, after this, we need to tell the index to let's see the I mi, right? Plus equal 1, right? If list in the C we look to these and we found the index. Right, so actually if okay, hold on, we actually should track the node though, right? List of list of I. Wait, do we even need index? It could just be a hash map, right? Right? Why not? A hash set. Python hash set remove time complexity. Okay, fine. And it'll just be this, right? 0, right? Set. Right. So then we just need to find the minimum element, right? Or this is called top list. Right, in top list, top, just call this top front, right, for node in front. So if this m equal n or n dot value less than, then m equal to n, right? So this will be m dot val, right? M dot val, right? M dot val. No. Hold on, zoom in, please. got a reference to this, we create a new node, and then we say, right, so if m equal none, then we remove them from the hash set. If m dot next not m dot next, right, then we remove m. Otherwise m equal m dot next, right? This node is not subscriptable. What? Oh, so basically we just do call list, right? Like that. This is not fun. Okay. Oh, bro. Oh, m dot val is less than m dot val, right? Or less than or equal, right? Or whatever. Memory limit exceeded. What do you mean? Why? Okay, so maybe we infinite loop here. For L in this, right? So this could be node, right? So we loop to them, trying to find the minimum node. If not F, what is F? Oh, F is here. The Y B dot next equal this node, B equal that, right? And we ask if the minimum, if it's not next, then remove, because this is the last element and we already have them here. Otherwise, oh, Y front and let's do this, and count is less than 5, right? Less than 5, then can we print the front? Somehow we have infinite loop with this. Oh, okay, if m, right, if we found something, right, because chances are it's already empty, right? Right, so somehow we basically loop until the list become none. How do we add the else if, so basically if else, right? Right, so if we, so let's just do 20, right? What is the count? If the count is less than 20, that means there's no more infinite loop. Final count, right? $20, but one, 3, 4, right? 2, 6, and 1, 4, 5. So somehow we couldn't find the M. Right. So this print could not find M. Do we say, let's just print the length of this. It's too annoying. It doesn't remove them at all. So something is wrong here. 4. We always find M. So what is M? What is M? Print the M here. Two. What? Why does it find 2? If M equal to none, or M is greater than, right? Not equal, right? And we always pick the minimum. Right. Final count still 0. Okay, we got 1. Good. Oh. So M here is the number, not is the reference. We need to tell the real reference to go there, right? Right, we need to tell this guy to go to the next. how do we do that? Let me check the phone. Okay, so right now the problem is we found the numbers, but we still have to make a reference to that somehow, right? Right? Right. So the question here is Python make the, so maybe a better approach would just be have a hash map, right? Because then you have the reference to them, right? Or in this case, we have to tell n, right? So n is none, right? So for n in front, and 1, basically n equal to n1, right? So we're saying we found m, and we say n equal n dot next, right? Because m only point to that and can't change that, so we have to do n. What the hell? Still doesn't change, right? Can we do a dictionary then? What? This is so stupid, right? So, or we can ask Gemini. In Python, how to make reference to a linked list. Change their value. Just one to make it go to the next element. I did that. Okay, so this is getting stupid. I think the problem here is, how do you do in Python how to make an element that is a linked list type, store in hashes point to next element, right? Yeah. Yeah, that's the hash. So in order for you to do that, yeah, let's do a map then. It's so stupid. So basically, yeah, just do a map. Um, but then now we have to do key value pair, right? Just do index, even though we don't care about index, right? But yeah, whatever. For I list in enumerate, right? Like that. Like that. So now we need to change them to mi again. For I and for and mi equal n I. Right? It stay the same. If the next is there, then we remove. Okay, we can just del front of mi, right? Otherwise, we have to say front of mi equal front mi next, right? Okay, so let's see if this passed. This should work now. If it passed, okay, fine. But the runtime is horrible, no? but probably fine for now. What time is it? So we have. Is there a better way? Whatever. Let's see. Next one. Okay. We might have to go in 20 or 30 minutes. So minimum operation to reduce teacher to 0. Okay, what is this question? Can we do Tuesday? Have a you are given what is it? A positive integer n, you can do okay. You're given a positive integer. You can do the following operation any number of times. Add or subtract a power of 2 from n. return the minimum number of operations to make n equal to 0. That sounds like a dynamic programming. Like if you see like operation any number of times, right? So at any time you can do power of 2. Okay, so it's not just add or subtract. Do S2 to 0. Okay, so now it become 40. Subtract. So now remember the Brian Cunningham algorithm? Right. Brian Cunningham. Right, so this is just end them. See, this is basically the iteration is 3, right? So basically from whatever number you have, you want to go to the next event, right? And then you just iterate them, right? You want to go to the closest you want to go to closest event, right? So see here, and then you do the Brian Cunningham algorithm here to get iteration, right? Is that so? So let's see. Number of set bit online. Right, I just wanna do some check. Can I input like what? Is that the case? Let's subtract a power 2 from it. Right, so is that the case? At least we know once we hit the even number, right? we get more water. Okay, so hold on. Does adding even to odd and does adding even to odd number result in even number, or does adding odd to even number result in odd number? Right? Mathematics. Right? What about does the analysis for even and odd as input and addition and subtraction as the operation possible, give the result as the table. Something. Okay, if we starting with even, we only end up in even if we add them even. If we start with odd, we want to add odd or subtract odd, right? Okay, so it doesn't matter. So if the number starting out at this, can we not minus 1 to be 38? Right? Number of set bit of 38. 3, right? So number of set it of 40, right? Does it even matter? 2 set bits. So if it's odd, right? If it's odd, it doesn't matter if you plus or minus. You can only plus or minus 2 to 0, right? Right, so 39, 40, right? What is this? Right, so if you are 38, so you are 38, no, 39, you can go plus, so 39 is odd, right? 39 is odd, you either you become plus or minus 1, right? Plus 1 equal 40. So then, right, or 39 minus 1 is 38, right? Or number of operation. So we have to do this, and basically we do right? So, or do we want to just simulate this, and if we see some cash, we should return that, right? Oh, so let's see. Okay, hold on. So 39 we want to go plus 2 to 0, right? The problem is the power of 2. So this is the option you have. Is crazy, right? Right. So this is 1 to 40, right? So this is what the thing said. We can plus. Why does it choose to subtract now? Because there's gonna be so many combinations, right? It choose to go to even. It choose to go to again. Keep adding. Because this is something special about the power of 2. Or what? So if you go to the power up to the next one and you minus yourself, then that's the best way, right? Is it? Right, so you have 2 to 0 is 1. 2 to the 1 is 2, right? 2 to 2 is 4. Right. So 2 to the 5, 32, right? 2 to the 6 is 64, right? So 39 decided to go to 40. Why is that the most optimized solution? Or is that something that we just like add, subtract, or whatever, right? Okay, I got 10 minutes. Let's think about it in a little bit. Right. We still have, we did this, still have this. So we know that you want to go to the next power 2, right? So basically you want to go, the next power 2 is 64, 10. Yeah. Is an optimization better than dynamic programming though? Right? right? So you want to go, if you add a number, what does it do to the number bit? Because you want the number bit to be all zero, right? So let's see. Python decimal to binary. We can do bin, right? To Python we have bin of 39, right? We start up with 39 and we want to arrive at 0 0 0 0, right? That means somehow we need, okay, bin of, flip all the bit at 0. Oh, plus 1, right? 2 complement, right? Oh wait, hold on. This way. Python bitwise operator flip it. Okay. You start with 39. Hold on. You flip all the bit, right? 0 0 0 1 0, everything 0, right? So what does binary 39 plus binary plus binary 40? So it seems like you want to zero out the best one you can, so that would be, you want to end with you look at the number bit, you want to zero out these, right? Right, that means you need to do the one go that you zero them out, right? And then you need to subtract 38, right? 0 0 0. So okay, so now you have 1 0 1 2 3, right? That's 8. Then you have to clear this, right? Right, so that is binary of 32. Again, so first you got 39, right? You become 40. That is, you trying to clear all of this. Okay, so binary of decimal 40. 0 1000. 1 0 1000. So this is right. So 0 1 2 3 4 5. 0, 1, 2, 3, right? So you want to clear these and these, right? So basically 0, 1, 2, 3, 4, 5, right? So does 39 plus 32, right? All right, I think it's lunch time, so let me continue this. So I have to cook and then probably play games, then we come back to this. That's it for now.